Hello and welcome to your favorite Shridevi Classes YouTube channel where we inculcate interest and confidence in science and engineering education. Today in our playlist Class 12th Physics, in our subject Electrostatics, we will discuss comparison of gravitational field and electrostatic field forces, and we will see similarity, dissimilarity and different characteristic of two gravitational field and electrostatic field. Let's start. We have to study equilibrium condition of a charge placed in air media with vertical position of another charge either below it or above it. We know every charge possesses mass, and in earth gravitational field all charged particle will have a vertical downward gravitational force acting on charged particle as per their mass and acceleration due to gravity, and force of gravitational action is vertically downward mg, and depending upon polarity of this charge we can place a positive or negative charge either vertically downward or vertically upward, such that that charge will produce an electrostatic force on this particle equal and opposite to gravitational force to maintain equilibrium of this charge in air. If this charge is a positive charge, we can place either a positive charge downward side or a negative charge at upward side to produce a force in upward direction, and if that electrostatic force become equal to gravitational force, then two equal and opposite force will neutralize each other and this charged particle will remain suspended in air in an equilibrium condition. This numerical example will enhance subject understanding. A charge of unknown magnitude q having mass 100 gram has to be balanced in air by placing a positive 2 microcoulomb charge below it at a distance 10 centimeter from it. We have to find out magnitude and polarity of this charge q. Now it is given that this charge has a mass of 100 gram or 0.1 kilogram, and that will have a gravity force vertically downward, and this charge of 2 microcoulomb got positive polarity, and to produce vertically upward electrostatic force unknown charge must be of like polarity, then only they could have a repulsion in vertical upward direction. So unknown charge got a positive polarity and let its magnitude is q, so the electrostatic force and gravitational force equilibrium condition would become that electrostatic force given by k 9 into 10 to the power 9, unknown charge q, given charge 2 microcoulomb, and the separation 0.1 meter, 10 centimeter is converted into meter, is equal to gravitational force m, and we can take acceleration due to gravity approximately equal to 10, and solution will result this value of unknown charge q as 0.1 to other side got change of position and it will come in numerator position, and this 9 to the 18 and power 10 to the power plus 9 and minus sign results in plus 3 go to denominator side to the other part, and by solution it will be 1 by 18 10 to the power minus 5 coulomb. So if this charge is positive charge of this magnitude, then even though it possesses 100 gram of mass, it will remain in equilibrium in air by the presence of this 2 microcoulomb charge that will produce electrostatic force equal and opposite to gravitational force. If one has to balance this charge by other charge placed at upward position, then that other charge has to attract this charge in upward direction and would have a negative polarity. In our physical world, four type of natural forces or field system exist. In nucleus of every atom, nucleons, neutron and proton have nuclear forces. In molecules, atom have weak interaction forces, and in electrostatics, charged particle have electrostatic forces, and in gravity, mass particle have gravitational force or fields. In some conditions, both electrostatic forces and gravitational forces coexist in our nature. Since all charged particle possess mass, so being charged they have electrostatic force, and with possession of mass they also have gravitational force. So there is a situation where we can compare both strength of electrostatic force and gravitational force. One such example is hydrogen atom, where proton got positive charge, electron got negative charge, and both have different amount of mass, and the two have a small separation of 0.53 angstrom or 5.3 into 10 to the power minus 11 meter. So the electrostatic force force is given as K and both have same Q electronic charge, 1.6 into 10 to the power minus 19 multiplied by 1.6 into 10 to the power minus 19 again, and the distance is 0.53 angstrom and force is inverse square of distance, and numeric calculation resulted in 8 into 10 to the power minus 8 Newton. Now similarly, proton got 1.67 into 10 to the power minus 27 kg mass, electron got 9.1 into 10 to the power minus 31 kg mass. The mass is very small, and gravitational constant Z, capital Z, got a value 6.67 into 10 to the power minus 11, and the separation is same of nucleus and electron, and both electrostatic force and gravitational force are inverse square force, and force calculation results in 3 into 10 to the power minus 47 Newton amount. And if we compare electrostatic force and gravitational force, we found that electrostatic force is very powerful compared to gravitational force in this case, and it is roughly 10 to the power 39 times stronger than gravity force. So we found that electric force is quite stronger than gravitational force, as in hydrogen atom or elsewhere, and gravity force is the weakest force of nature, and gravity force between two mass is always attractive type force, but this gravity force is applicable to all distance positions. That means it applies within nucleus, among nucleons, and in subtler objects between Earth and Sun. The gravity force is also applicable. Compared to gravity force, electrostatic force is quite strong force, and for opposite polarity it is attractive in nature, and for like polarity it is repulsive in nature. But this Coulomb's force is not applicable to all distance position within nucleus, among nucleons, proton and neutron. We presume that electrostatic force won't exist. If we consider electrostatic force among protons of an nucleus, it will make stability of nucleus doubtful. So we presume that electrostatic force is not applicable to very small nuclear distances. Dissimilarity and similarities between electrostatic forces and gravity forces is important topic of our examination. So let's first study the similarities between electrostatic force and gravity force. Both obey inverse square relation. That means if you double the distance between particles, and if they are charged particle, the electrostatic force will become 1/4, and if they are mass particle, the gravitational force also become 1/4 at double distance. Both electrostatic force and gravity force act along the joining line of two interacting body. That means both are having central force tendency, and such central force doesn't depend upon presence of other similar nature charges in surroundings, as they are interaction of only two interacting bodies, and such central force also configure a conservative field around themselves, where amount of work done in a closed loop is always zero. So both electrostatic force and gravitational force produce conservative field. Both electrostatic force and gravity force can work in vacuum without any medium. So this is again a similarity. Let's talk about dissimilarity between electrostatic force and gravity force. The gravity force depends upon mass and not on charge, whereas electric force depends on charge and not on mass. Electric force is very strong compared to gravity force. In fact, gravity force is weakest natural force. Gravity force doesn't change with medium, as constant used here for gravitational force calculation, capital G, is medium independent, but electric force do depends upon medium property, and it is inverse function of medium permittivity. So for a medium of higher permittivity, electrostatic force will decrease. Gravity force is only attractive in nature, whereas electrostatic force got both attraction and repulsive nature. In relativistic speed conditions, when particles are moving with a very high speed, closing to speed of light, mass starts changing in a relativistic manner. So with that change, gravitational forces also changes, but amount of charge will not change with relativistic speed. So electric force is non-relativistic. So these are important dissimilarity between electrostatic force and gravity force. We presume that this learning video has enhanced your understanding about electrostatic and gravitational field, and now you can not only compare the two field, you can also get knowledge of similarity and dissimilarity between electrostatic forces and gravitational forces. If you feel this study material valuable, do share it with your friends and do join YouTube membership of Shridevi classes to get more from our side so as to achieve better understanding and real success in today's competitive world. Thank you very much.